Yeah, sorry, participants, due to some this internet problem, it's got disconnected. Okay, so simple. The idea is you have data to be collected. Okay, because the big problem in this machine learning, data science, or data analytics, the problem is the data. You have to identify the actual or real-time data for your research. It's a very tedious process. Okay, so the data collection plays a major role, number one. Number two, once the data is collected, you have to pre-process the data because the data may have dirty. Okay, it means it may have some missing values, or it may have some noisy data, or there may be some redundant data or duplicate data. So we have to pre-process the data. For example, you are trying to prepare a biryani. Okay, so while preparing biryani, what you will do? You will collect a chicken, or you will collect the vegetables from the shops. So the question is whether everything is available in single place. No, we have to go to the different shop, vegetable shops, to buy the vegetables, and we have to go to the chicken shops to buy the chicken. Now we got everything. So that's called as data collection. And after that, what you will do before preparing the biryani? You will use everything as it is? No, you will wash the rice. You will wash the rice and chicken and so on. Why? You know that there may be some dirty. Okay, so like that here also in data analytics we have to clean the data. That's called as data pre-processing, right? So you will wash the chicken, you will wash the rice. That's called as data cleaning. Then what you will do? You will cut the chicken into pieces. You will cut the onion into pieces. That's called as data transformation. You have to transform one form to another form. Okay. Then what you have to do? You have to do the data reduction. You might have purchased half kg of chicken and you might have purchased 1 kg of rice, but the what is the ratio in the biryani preparation? You should have equal ratio, right? Half kg of rice and half kg of chicken. So you may have large amount of data, but all the data are available, very much required for your task. That you have to see. If it is not required, for example, I want to compute the grade. I want to classify my student as excellent or average. For that, if I need only the student name, number, and the grade, I can do that. I don't need a student mobile number, address, and so on. Right. So in that case, I am going to omit that attribute. I'm going to exclude it. I'm not going to include it. Okay, that's called as data reduction. Okay, then once you have everything, then what you will do? The biryani preparation, will keep the vessel and you will put everything together. That's called as data integration. And which method you are going to adopt to prepare a biryani? That's called as your data analytics. Okay, are you going to apply supervised learning? Then it will be Hyderabad biryani. Are you going to apply unsupervised learning? Then it will be Amur biryani. Okay, so which methodology you are going to adopt to mind the pattern, to discover the pattern? Okay, that's called as the methodology or data analytics method you are going to adopt to discover the pattern. So as I said, no, data is the new oil. Data is the new oil, right? So since all the complete economic of the world, which depends on data today. Okay, that's why now people are focusing more on learning, machine learning, data science, data analytics, right? So it plays a major role. So what is PDA? PDA is defined like this. Predictive analytics is the use of data, statistical algorithms, and machine learning techniques to identify the likelihood of future outcomes based on historical data. So what you are going to do, you have some empirical data, and by using that, you are going to train your model, and the model is going to react as per the data which you supplied as an input. Okay, that's called as a predictive analytics, right? So which something which is unknown to us, that you are trying to predict. For example, you want to predict whether the patient has COVID or not. Okay, so for that you can develop some predictive analytical method model. Like tomorrow there will be rain or not, we can develop some forecasting model or prediction model, right? So what has happened to providing the best assessment of what will happen in the future. So what you are trying to do, we have some data, okay, with us already, some historical data. By using that, you would like to build the model, and the model will predict what will be the future. Okay, that's called as predictive analytics. So when you look this predictive analytics, there are two type of predictive models we have. As I told you already, there are one is classification model, and second one is the regression model, right? So in the machine learning, we have two, right? Basically, we have three: supervised learning, unsupervised learning, and reinforcement learning. Forget about the learning. We are focusing on supervised and unsupervised. So this supervised learning is called as predictive analytics, and unsupervised learning is called as descriptive analytics. So in this predictive analytics, we have classification methods and regression methods. Okay, right? You will see. So what is classification? Classification model predicts class membership. Okay, and what is regression model, which predicts a number? What it means? If I say like this, you may not get a clear picture. Just I'll open a notepad and I will show you. Let us take this example, or I have one more data that I will take. Are you able to see the Excel file? It is visible to you? Excel
Yes,
file?
it is.
Yes, sir. Yes, sir.
Thank you. Now, this is the famous example to explain the predictive analytics, or you can say classification model. Okay. Now, what happens actually? Data is represent the form of information table. Everyone knows that data is represent the form of information table. There are two type of attributes we have in the information table. What are the two attributes? Let us take this example. This is the data set, nothing but a small bank data set. How you can say this bank data set? Bank manager, right? He is getting more applications to issue credit card, right? So for that, what he decided, he thought of developing some prediction model, whether the credit card can be given to that particular customer or not. For that, he would like to know whether the customer is genuine or cheating customer. Okay, so how he has some data because already the customer has availed some loan from the bank. Okay, so whether he has refunded that EMI regularly or not. So refund is yes, means that guy is refunding the EMI regularly to the bank. Okay, no means he is not paying, he is irregular paying the EMI. And marital status, you know that today life is running by EMI. We have personal loan, home loan, and car loan, and so on, right? So it means you got married, right? So you are more committed. So if you are more committed, you may be missing some EMI per particular month. There is a reason. So that's why they have taken another parameter called as marital status. If you are single, you may be paying the EMI, but still some people are paying the EMI regularly. So you have taken another parameter, marital status is single or married. Then the third important parameter is the taxable income. Okay, greater than 80K, we have taken two thresholds, greater than 80K and less than 80K. Then cheat. Okay, so it has two values. No means the customer is a genuine customer. Cheat is equal to yes means yes, he is a genuine, he is a fraud. Okay, he is not paying the, you can't say fraud, he is not a genuine customer. It means he is not paying the EMI regularly. Okay, so once if the customer is genuine, it means cheat is no. Then what you can do? The manager can take a decision. Yes, the credit card can be issued. Okay, so you will take a decision. Yes, okay, credit card can be issued. Okay, so his job is getting reduced. That's why you are using this kind of prediction models, right? Even though you are developing a prediction model, you need the domain expertise. They have to decide the outcome of the model. They have to validate the model. You may be, some people will say, yeah, I'm working on healthcare analytics. But how many people are getting help from the doctor? Once the model is developed, how many people who have validated the model with the doctors, right? So it depends upon the application. You should have the domain experts. Okay, then only we can say that the model is good. Even though it produces the accuracy of 90, 95, it should be validated by the proper domain expert. Okay, right, we'll come to this problem. So in this case, we have serial number, a refund, a master status, a taxable income, and cheat. Now, based on which attribute I can classify the customer as genuine customer or fraud customer? Any idea? Anyone? You can unmute and tell me. Anyone of the participant? We have serial number, refund, master status, taxable income, and cheat. Which attribute I can do that?
Refund, marital status, and taxable income. All three will help to determine.
No, all the three attributes are helping to get the outcome of cheat, right? So here, cheat is the attribute which helps us to take the decision whether the customer will cheat or not, right? Okay. I hope you are getting my point. Refund, martial status, taxable income. Based on this, you got the value of cheat. Okay. So here, I would like to classify the customer as genuine customer and bad customer. So based on which attribute I can do that? If cheat is equal to yes, is a fraud customer. If cheat is equal to no, is a genuine customer. Correct? So the cheat attribute is called as a decision attribute. The cheat attribute is called as a decision attribute. What about all the remaining attributes? All the remaining attributes are called as conditional attributes. All the remaining attributes are called as conditional attributes. So here the refund, serial number, martial status, taxable income are called as conditional attribute, and cheat is called as decision attribute. You can call it as decision attribute like this, or another name is class label. Another name is class label. You can call it as a class label or label attribute. Simple. Okay. So when you go for a predictive analytics, for the system, you have to say in your data set which attribute is a class label. Keep in mind, whenever you are trying to develop your model, or you writing in Python or in R or RapidMiner, you have to inform to the system which attribute in your data set is going to be the class label. You got it? What is class label? Class label is nothing but one of the attribute in your data set which is used to take a decision on the classification. Okay, that attribute is called as a decision attribute, or you can call it as a class label. Clear? Okay. Now, so what is supervised learning? In supervised learning, you may be notice that the data will be given to the machine to learn from the data. You will be supplying some data to the machine, where with the data you will also supply the class label. So here we'll give the refund, martial status, taxable income, and apart from that, we'll also give value of the class label. That is the decision attribute to the system, so that the system will be trained. Okay. Now, what happens in case of predictive analytics or supervised learning? The data to be divided into two: training and testing. You may be most of you may know this, right? You should have training data and testing data. The data to be divided into training and testing. How you can divide? Any idea? Any participant? Yes, it should be a two-way communication. Anyone? How you can divide the data into training and testing? Randomly, Professor Vikas Dubey says randomly. Randomly means any ratios there? Yeah, you can put in chat box also. I'm seeing chat box. No problem.
So 70-30.
70. Krishnaveni madam says 70-30, and Rama Bansai says 80-20. Nandakumar Mishra says 80-20. Mittal Desai says 77 and 33. So almost it's similar. Some people are saying that it's 80-20. Some people are saying that it is 70-30. Okay. So it depends. It depends on the people. You can see here. I have no, that's why I have specified two. 80-20. Some research group follows 80-20. 80% of the data will be considered as training data, and 20% of the data will be considered as a testing data. Okay. And some people says no, we can consider 70% of the data can be a training data, and 30% of data can be considered as testing data. But when you do so, what will happen? If you do randomly or manually, what will happen? What problem you used to get? Anybody? What problem you used to get? Hmm?
Sir, we will get different types of result if I considered randomly. If I take the training and testing it randomly, each time we
Okay,
will
some
get
says wrong.
separate.
Okay, Divyajyoti boss sir says we'll get get different result, and some says
It may
underfitting.
lead
Yes,
to
Nandakumar.
it may lead
Yeah,
to overfitting or
yes,
underfitting also.
Doctor. Yes, Doctor Ahmed Kumar says overfitting and underfitting. I hope. Yeah, that's fine. Yeah, we'll get overfitting, underfitting. Yes, Vijay Saran says overfitting. I think you can have one more terminology here: unbalanced data set. I hope you might have known this, right? Unbalanced data set. Your data may not be balanced. What do you mean by unbalanced, or what do you mean by balanced? Suppose, let us say, in this example, here you can go to the Excel. You can see in the class label how many classes we have? Two classes, right? Cheat is equal to S is the one class. Cheat is equal to no is another class. Now let us say, while dividing, I have taken only no as the training data. Okay, I don't have any yes. Let us say there is a 10 row here. So I am following the 70 and 30 ratio. So 70% of the data, all the no classes will be considered as a training, and S class will be considered as a testing. Whether the model will work properly, whether the model will work properly, no, it cannot. It cannot predict the S class, because there is in the training data there is no S class at all. We have only no class. Okay, so the model will analyze only the no class. It will not able to predict the S class. That's called as, yeah, I will come to that. What should be the best? So in that case, no. What happens? You will get unbalanced data set. So to overcome that, there is unbalanced data set is one of the research area. People are many research papers are there in the unbalanced data. Just to try to explore it. Okay, so instead of doing randomly or manually, what you can do? You can use some method to divide the data into training and testing. So one of the standard method is cross validation method. You may be knowing this. Okay, cross validation here it is there. Cross validation method. It's called as cross validation, or you can call it as cross K validation, right? So what is that? K is K indicates K is nothing but the number of foldings you are going to perform, and you are going to divide your data samples into training and testing. Correct? So cross validation is a method which helps to divide your data into training and testing properly. Okay. Once the data is divided into training and testing, this is the flow. So there are two-step process involved in the classification. One is building the model. What do you mean by that? Building the classifier. You have to build the model by using your training data. So take the data as the input, take the data as the input, okay, and it means and then divide the data into training and testing. So you have two, phase one, phase two. Phase one, we have training data, then apply your machine learning algorithm, or you can call it as a supervised SML. I can say here SML, supervised machine learning algorithm. Okay, right? So there are many supervised machine learning algorithm, right? What are the class? All the classification methods are called as supervised machine learning algorithm, like decision tree, naive Bayesian, and K nearest neighbor, support vector machine, random forest, neural network, rule-based classification, rough set classification, fuzzy set classification, and so on. You can apply any one of the machine learning algorithm, supervised machine learning algorithm on this training data. You will get the model. You will get the prediction model here. Simple. So this is the flow. Data to be divided into training and testing. Then consider the training data. Apply your supervised machine learning algorithm on the training data. You will get the model. Okay, that model is called as a classifier, because here we are trying to do classification, right? So that's called as classifier, or you can say prediction model. Now the model to be tested. Okay, the model to be tested whether it works fine or not. So you want to see the performance of the model. Okay, so you are going to apply the model which you developed, okay, on the testing data. Okay, we have already testing data. So now the whatever the model which you built by using the training data, that model will be applied on the testing data to see the performance. To see the performance. Okay, if the performance is good, okay, let us say some 70, 80 to 90, then this model will be used to analyze a new data set. Okay, let us take an example. There is one more guy. 11th, and refund is yes. Martial status is single. Taxable income is greater than 80K, but cheat is question mark. It means that value is unknown to us. Okay, we have to predict. What is classification? Classification is a process which predicts unknown class label. Okay, so for this given data sample, the class label is unknown. That you like to predict by using the model which we built. Okay, this is the flow in classification. So the training part, this part is called as model building. Okay, or you can say model construction, and this testing and performance is called as model usage. So there are two-step process involved in the classification. Is it clear as of now? I will explain in the implementation so that you will get uh, more clear picture about this. One minute. So there are various tools we have actually. There are various tools we have. Even it is there in the my PPT. You can see. Yeah, these are the various tools we have. Like no, we have Clementine, and earlier it is called as Clementine. Now it is called as IBM PSW Modeler, Predictive Analytical Software Modeler. Then we have SPSS Statistics. These two products basically from SPSS, SPSS Clementine and SPSS Statistics. And IBM took over the company, so it is now renamed as IBM PSW Modeler and IBM SPSS Statistics. Then we have SAS Miner. Everyone knows this. It's mostly used by the MNC companies. Okay, costlier tool. Then you have Statistica DB Miner, but now it is renamed as Grid Analytics. Okay, that Statistica DB Miner tool is called as Grid Analytics. That's the new name. And then we have Rapid Miner, which I'm going to show you the demo. And Veka is one of the good data mining tools. Okay, people have used it, which is developed in Java. And then R, we have R programming, like it's a statistical software which supports our data analytics and big data analytics and so on. And then you have one more, it's called as Python, but I used to call it as a Python because no, it's dominating the complete world, right? People are using like anything. Okay, right? So particularly in our data science and data analytics and machine learning, right? There are a lot of libraries. So easily we can develop models by using Python. So Python, I used to call it as it's a tool for data science and data analytics and machine learning, right? So many of you may be expertise in the Python and you may be using it. So I want to show you something different. We have another tool called Rapid Miner. When they have released it, no, at the time it is completely open source. Up to Rapid Miner Studio, it is completely free. Okay, then after that, no, it has its own demand. Then so they converted the tool into license and open source. For everybody, it is licensed. We have to pay and use it. It's only open source for a faculty or instructor, a student, and research scholars. Okay, so you have to get education license. You have to get education license. Okay, then you can use it. How to do that? Just I will show you. Are you able to see the rapidminer.com? Are you able to see my browser? Yes.
Yes, sir.
Yes, sir. Thank you, sir. Thank you. Right. So rapidminer.com. This is a website where you have to go and download this tool. You can see here. Get started. Okay. Now you can see here Rapid Miner Go, Rapid Miner Studio educational program, right? So you can see use ML for academic purpose as a student or professor. Apply for Rapid Miner education license strictly for academic purposes. This license provides free access to Rapid Miner Studio and Rapid Miner AI Hub. Okay, so we can use this Rapid Miner Studio, right, which gives the free access. For otherwise, no, it is a commercial. Okay, so you have to apply. You just click this, and you will get this another page. It will ask your information for education license. Sorry, you just enter your institute mail ID. Okay, so that it helps us. It helps to understand that you are faculty or a student, and choose your role, whether you are a student or researcher. If you are a research scholar, you select researcher. If you are a student, you select student like MTech students or BTech student, professor or instructor, and then name of university and name of the course. For example, there may be some course on machine learning here. You can specify that the course number will be there and course term it will be there, the name of your professor. Then download it. Okay, and then you will get your link, right? You will get the tool here, download and install it. And then after installing, no, you have to go to that mail. There you might have received some activation link. Just you have to click that. Then whatever the tool you have downloaded will be activated. So you can use it. This is the way to get this tool. Okay, it's very easy. Okay, it's very easy. So just do it and try to get the tool, install it, and just listen. I'm going to show you the demo how to implement a predictive, how to develop a predictive model. Okay, how to develop a predictive model. Okay, by using Rapid Miner. Just listen me, my flow, and if you have any problem, let me know. Okay, you can stop me then and there also, no issues. Yeah, this is the window of Rapid Miner. Okay, so when you look this Rapid Miner, no, there are 4 areas. I used to always divide the window into 4. This is called as process area, or you can call it as no. um uh, this white space, no. Here you are trying to build process. What do you mean process? Process is nothing but flow of data. Okay. So what is the system? You are going to have a data, input data, and you are going to feed it to the system, and system is going to mine the data, and it's going to discover the pattern. Correct. So that you are going to do here. But when you are trying to build the process, right, here all the functionalities are developed in terms of operators. Okay, all the functionalities of your data analytics are developed in terms of operators, and you can connect this operator and then you can achieve the particular task, right? So you can see in the left down, it's called as operators. I hope you are able to see. Are you able to see my Rapid Miner window? Anyone can please confirm it?
Yes, we can see.
Anyone please confirm? Right. So here you can see this is very important. Operators. Under that there is a small search box here. What is the use of it? Suppose you may be instead of going and accessing the particular operator, if you know the name of the operator, you can type. Okay. For example, I want to read the data, so read. Now you can see immediately we are getting the operators which are relevant to this read. So read CSV, read Excel with format, read URL, read SPSS, and so on. Right? This is the one way. Or you have data access mainly used to read the data and write the data. So if you click this, we have files where you can see read and write. Okay, you can have different operators to read different type of data. Then write also, you can write the data. Then you can access data from the database. That is also possible. Okay, and you can access data. For example, I am working on text analytics where I am connecting the tutors and I am trying to read some tutors directly. Okay, through Twitter API. Then you can do that. Okay, you can see. You can see search tutor, get tutor users, stat users, get tutor user details, get tutor relations. Yes, you can do that. Not only that, I have stored some data in my cloud in Amazon S3 because the data is large. So I'm not able to accommodate in my laptop, right? And I want to access it. Yes, we can do that. We have cloud storage. Okay, there we can see retrieve and store. Okay, you can have retrieve and you can see under the cloud storage S3, Amazon S3. How to read data from Amazon S3 if your data is stored in Amazon S3. Okay, and write Amazon S3 and so on. Then Azure, right? You can do with the Azure data lake storage and Dropbox, Google storage, right? Read Google storage, okay, write Google storage and so on. So we can do all the things, okay, which are available in the read access or data access, you can say here. It's nothing but the data access. Then the another important thing is modeling. Modeling is nothing but your complete models like supervised or unsupervised. If you click here, you can see the first one itself is a predictive. Okay, I hope you are able to see that. The first one itself is a predictive. Okay, and then you have segmentation. Segmentation is another name for clustering, which comes under unsupervised learning. Okay, and then we have association, which also comes under descriptive data analytics, and correlation. Then to find the similarities. Okay, right? Then future weights. There are many things. You can weight the futures. Okay, then you can go for optimizations, right? So there are various methods we have, right? Now our objective is to develop some predictive model by using RapidMiner. So the first one is to read the data. So simply I will go for read. Since my data are in Excel, I will use Excel or CSV. Since my data are in Excel, I will use it. Read Excel. So what you can do, how you can do that? The one is how I have done. I have dragged and dropped, right? This is the one way. Or we can just add this. Just double click this so that that particular operator will be added in the process area. Read Excel. Okay. Then you can see the operator. This is the operator. There will be input port and output port. Since this is the first operator, no need to do anything with the input or port. Okay, and but there will be output port. If it is not connected with the next operator, then it should be connected with the result port. There will be a result port here. Okay. Now, what is the objective here? You want to read some data. Okay, so keep your cursor on read Excel, and you can see there is a one more area in the right hand side. It's called as parameter area. Whatever the operator which you are adding, there should be some parameters which should be supplied by the user. You are the user, right? We are the end user, right? So you have to give some input to the system. Like for example, if you are going to use k-means clustering, then what is the k? Number of clusters. Okay. If I am going to use k nearest neighbor, then what is the k? Right? How many neighbors you are going to consider? Right. So even though the machine is going to learn, you have to supply some input to the machine so that it will learn accordingly. Correct. Right. So this is nothing but the parameter window or a property window. Okay, so for each operator, there will be some set of properties. For example, Excel, you can see Excel file, which file you would like to read. And you know that the Excel made up of various numbers, which sheet 1, 2, 3. So which sheet has the data that you have to specify. Okay, for example, sheet number you can specify, and which sheet has the data that you have to specify. Okay, now I will show you one example here. Read Excel, you can just browse the file. Right. Okay, let us take this data set. All right. Then so now I want to run this process. Okay. You can see the blue icon. Okay, to run the process after F11. So it's executing. Now you can see this is the result. We have some data and just I want to read the data. Okay, same data which I explained you. Refund, marginal status, taxable income, unchecked. where the cheat values are missing here. Okay, that as of now, just leave it. I will explain it. So you must know how to read the data in rapid manner. This is the way to read the data. But what is my recommendation? Whenever you go for predictive analytics, I told you, right, we have to inform to the system which attribute in your data set is going to be the class name. That you have to specify. Okay, so if you want to do it, there is another way in the rapid manner we can use set role. There is an operator called set role. But instead of doing that, we can, instead of supplying the Excel file here, use this configuration wizard to download the data. Okay, so now I am downloading the data, import configuration wizard. Then it will, you have to read the data, you have to select the data. So this is the data which you are discussing, the bank data set. And this is the first window where it asks which sheet has your data, because you know that the Excel, there will be many sheet and each sheet may have some data. So which sheet data you have to consider. So basically it will be sheet 1. And if you want to change it, you change it. Right. And then what is the still range of the data? Okay. Right. Then next. Now you can see the serial number, the data is visible, right? And you can also note down here, there is a small drop down link here. You can just click this. You can do 4 things here. You can change the type of data. You can change the role of the data, particular attribute, and you can rename the column. Okay, and you can also exclude the column. It means that column may not be important for your classification, so you can exclude it. For example, the serial number is not much important here, so I would like to exclude it. Simple. It will not be considered. It's a way, one way of manual data reduction. And then you have to say that which attribute in your data set is a class label. So cheat is a class label, right? So select change role. You just select and label. Or sometimes no, you will be setting that attribute is ID, or sometimes you will be giving more weight to that attribute. You can do that. But as of now, for the predictive analytics, we must know we have to set which attribute is a class label. Okay, so that only I am doing it, doing here. Then finish. Then finish. Now you run the process and see. Okay, so this is the data set we have read, and you can see here that cheat attribute values are in different color, like slightly blue. So it indicates that this is the class label. Okay, you are informing to the system this is the class label. All right. So the first process is done. What you done? You have the data. You have the data with the class label. Now we have to divide the data into training and testing. Correct? What is the first step? Model construction. How will do that? Divide your data into training and testing. On training data, you apply your supervised machine learning algorithm. So here also, I am going to call another operator, cross validation. Okay. So you are able to see that operator. Just copy or drag and drop here. Now, what is the difference? You are able to see here. The operator has double line, double box. Okay, if it is a double line box, it indicates it is a nested operator. It means inside it has some functionality. Okay, inside you have some functionality. So double click this. Now you can see inside this we have training phase and testing phase. I hope it is in also in white color. So I hope you can able to see training and testing. So what is the role of cross validation? The cross validation divides the data into training and testing. Okay. So if you double click it, it goes to training part and testing part. Clear? As of now, one more thing we have to do. we have to supply this data as the input here. We have to supply the data as the input. Okay. Now then we go to the training phase. What you will do in the training phase? What you will do now? The training phase. You will apply any supervised machine learning algorithm on the data and you will try to build the model. Yes or no? Correct? So we will try to first divide the data. In the training phase, we will apply any supervised machine learning algorithm on the training data and then you will try to build the model. So now, as I told you, there are many classification algorithms we have, right? You have decision tree, you have the Navy Bayes, you have random forest, and so on. So now I will show you one algorithm how to apply this in the tool, and then I will explain that algorithm theoretically also. Okay, right. So go to the tool. Now training, in the training phase, we have to apply the supervised training algorithm. So I would like to apply Bayesian. But just simply I will type Bayes so I can see modeling predictive under the Bayesian we have Navy Bayes. So had it here. Now that cross validation divides the data into training and testing. So you got the training data in this port TRA, and you can see under the testing phase you have testing data. So the data is divided into training and it is there in the training port, and the testing port, the testing data is there. Now what you have to do, you have to apply any machine learning algorithm, that is supervised machine learning algorithm on this training data. So here I have considered the Navy Bayesian is one of the supervised machine learning algorithm. So I am going to supply my data as the input. Okay. Then, so this Navy Bayesian, okay, inbuilt, the functionality is inbuilt. So based on this data, the model is developed now. The model is available. You have to supply this model as input here. Now the testing phase, the model which has the model which you built and the testing data. Correct? Okay. So now what you have to do? We have to see the performance of the model. So we have to apply this model on the testing data. So you can select apply model. We have apply model. Okay. Then the model to be connected as the input to the model. And we have testing data because the idea is you want to apply the model which you built on the testing data. Okay, so the testing data will be the one input and modeling will be the another input. Then you want to see the performance, so I will add a performance. Okay, you have performance. Now you just connect this label alone, because with the label only we can able to identify the performance. Then you connect this performance here. Okay, and you can keep your cursor on performance so that you will come to know what are the properties for this performance operator. See, these are the parameters for the performance operator. So the first one is accuracy. It's a default. Whenever you try to build a model, everyone will look for what is the accuracy of the prediction model. Okay, so it is selected default, or if you want to see the classification error, you click and then recall and then precision. We will have a discussion on this. The after completion of this predictive models, then we will discuss it. Okay. Now, see you are where you are now. We are inside the cross validation. Okay. So if you want to go back to that, you can see here under the process there is a blue icon. Okay. Just click that. We will move back to the your main design area, right? And now you can see. Now you want to see the model, connect it. And so you want to see the model, connect it. Then you connect the performance. If you want to connect the testing data or original data, whatever you want to see, you can connect it. Okay, then run the process. Right. So this is the performance vector, performance of this model. 60% is the accuracy. Okay. What is this? This is nothing but the confusion matrix. This is nothing but the confusion matrix. I will come back to this later. Okay. And this is your simple distribution Bayesian model. Okay. Now, what you did, you have developed a model. Okay, and you check the performance. Performance is 60%. Okay, but later for this data and this model may be giving 60. If you improvise it, it may be giving further 70 or 80. Let us assume this this accuracy is good accuracy. Let us say I fix the threshold. If that model accuracy is greater than 55 or 60, then I will consider it a good model. Okay. I want to apply this model. What is classification? Why you have to do the prediction model? Why you are studying this predictive analytics? Because you want to predict something which is unknown to us. Okay. So the first and second phase is over. Model construction is over and model usage is over. Okay. We have constructed the model by using training data, and then we have tested the performance of the model using testing data. So that is also over. Now you want to apply this model or you want to use this model, okay, to predict which is where something is unknown to us. Now let us take this example data. Are you able to see my Excel sheet? This one where sheet is unknown. Yes, anyone? Are you able to see my Excel sheet, sir or madam?
Yes, sir. Yes, sir.
Now
Yes,
you
sir.
can see. Thank you. Now you can see now the same data, but you don't have cheat values, right? Right. So this is a new applicant. This is a new applications submitted to the bank. Bank manager has already given the old record to the machine learning expert to develop some prediction model. So the model is ready now. Now he has received some 14 applicants. Now you want to decide whether the customer will be cheating or not. So you want to predict. Okay, you don't want to do manually, right? Since he has developed the machine learning model, you want to use it. Okay, now you have built the model just by using Navy Bayesian. You are going to apply this model for this data set where the class level cheat is unknown to us. Okay, how to do that? That I will show you in the demo. Okay, now go back. So read once again, read Excel since your data are in Excel. Okay, now use the import configuration wizard because even the whatever the data you are going to read, where you have to set the class label for the classification. Sorry. Yeah. Now you can see, right, the cheat where you have able to see the question mark, right? So it indicates that there is no value for that. That you have to predict, which is missing. Okay, and what do you have to do? We have to set. We have to inform to the system which attribute is the class label. Okay, so cheat is the class label. Change role is equal to label. Okay. Right. So we have to inform to the system which attribute is the class label. Then finish. So this is did Excel. Okay. Then apply model, because what do you want to do? We have built the model. Model is with us. It is there here. The model is with us. Now you want to apply this model on this new data set where the class level is unknown, which you would like to predict it. Okay. So you disconnect this and you take this apply model here and supply this model as a one input, and then this data is another input. Okay. And it's going to predict what is the, which one I'm trying to do, this file. This for the 14 records, I want to know what is the cheat value, whether it is yes or no. Okay, for that I am using the model which I developed, right? So I am using apply model, okay, to apply the model which you developed on this data set, unknown data set, correct? Then you execute, and if you want to see the model also, you can connect it, no issues. You can see here, I hope you are able to see this result. The 14 records where the cheat value is unknown. Okay, now you apply the model which you developed on this data set. It's predicted. See here, the first tuple, it says cheat is no. It means the person will not cheat. And if you take the fifth tuple where the cheat value is yes, he may be cheating. How it is happening? Which algorithm I have used here? I have used Navy Bayesian. What is the logic of Navy Bayesian? The Navy Bayesian basically depends on the Bayesian Bayes theorem. Okay, Navy Bayesian comes from Bayes theorem. What is the Bayes theorem? This is the Bayes theorem. P of h by x is equal to P of x by h, P of h divided by P of x. All right. So h is the hypothesis, x is the data sample, and we have two probability here. Okay, one is prior probability, another one is posterior probability. And P of h and P of x are nothing but the prior probability, and P of x by h is called as posterior probability. In P of h, simply will predict the hypothesis. Okay, we will not bother about the samples, right? So whether the, for let us say we have some fruits, okay, and check the sample, like whether it is round and color is red though, then it may be happy. So where based on the data sample X, the hypothesis is framed. But here we will simply say fruit is apple. We will not bother about whether what is the shape and color. That is P of H. Prior probability. What is P of X by H? With respect to X, the hypothesis, whether the hypothesis holds the data sample X. Okay. So that's called as prior probability. The P of X is constant for all the classes. Okay. So you are not going to consider. So you will compute only the numerator. That's the Bayes theorem. Now, here we are going to convert the Bayes theorem into Bayesian classification. So you have P of, instead of H, we will have Ci. Okay, what is that Ci? I may be 1 to m. You can have any number of classes. Okay, you can have any number of classes. So P of probability of Ci divided by X is equal to P of X by Ci multiplied with P of Ci. P of X by Ci multiplied with P of Ci. So you can do any one of this, right? I am not considering the P of X, actually divided by P of X. Since P of X is a constant for all the classes, I am not considering it. I am only computing the numerator. So this is the formula. Okay. Now you have to compute P of Ci by X equal to P of X by Ci and P of Ci. Now, what is I? I is equal to I is equal to 1 to m, right? You can have any number of classes. If you have two classes, I is equal to 1 comma 2. If you have three classes, I is equal to 1 comma 2 comma 3, correct? Right? Now this problem I will explain. This is the example you have to take. Okay, and we have age and income, student, credit rating, Bytes computer. So this is the one another example, Bytes computer example. Like no, these are the some people data. Now you will have to check whether the people will buy a computer or not. For let us say the first row, what is the interpretation? When the person age is less than or equal to 30, and in case the income is high, and he is a student, and his credit rating is fair, and he may not buy a computer. Bytes computer is equal to no means he may not buy a computer. What about third row? A person age is between 31 to 40, and his income is high, and he is not a student, and credit rating is fair, and then Bytes computer is equal to yes. So this is the data. Now you can see, I told you the data is represented in the form of information table, and there are two type of attributes. So age, income, student, credit rating are called as conditional attribute, and Bytes computer is called as decision attribute, or you can call it as class label. Now how many values we have for the class label? Two type of values. Bytes computer is equal to yes is the one type, and Bytes computer is equal to no is the another one. So it means there are two classes. There are two classes in this data set. Okay, class 1 and class 2. We'll go back to this. So I have considered C1 is a class that is Bytes computer is equal to yes. Okay, and what is the class 2? Bytes computer is equal to no. Now we have to compute this. So we have to compute. P of C1 by X. I'm just replacing I by 1, first class. So okay, and then I is equal to 1 comma 2 in this case, right? So we have two classes, right? So P of C2. Right? So you have to compute. You have to compute probability of C1 by X and probability of C2 by X. And which class produces the maximum probability, then we can conclude that X belongs to that class. It means if suppose P of C1 by X is greater than P of C2 by X, okay, then we can say that X belongs to that class. So we have to compute the maximum probability, which class produces the maximum probability, then we can say that X belongs to that class. So in this given data, the data which I have shown here, okay, so if you look the data, there are 14 tuples. There are 14 tuples. You have to check how many tuples which belongs to yes, how many tuples which belongs to no class. So just take the Bytes computer value, how many tuples which belongs to Bytes computer is equal to yes, 1, 2, 3, 4, 5, 6, 7, 8, 9. So can I say the probability of class 1, that is Bytes computer S, is nothing but 9 by 14. There are 9 tuples which belongs to S class, and divided by total number of data in the total number of rows in the data. So 14, 9 by 14. What about the second one, probability of C2, which is nothing but Bytes computer is equal to no. So there are 5 tuples, 5 by 14. So which I have done already. Probability of C1 is equal to Bytes computer is equal to S, 9 by 14. Probability of C2 is equal to Bytes computer is equal to no, 5 by 14. Now this is the data which is given to us. What is the data? X, one more data which is where the class level is unknown. Age is less than 30. Income is equal to medium. Student is equal to yes. Credit rating equal to 5. But by what is Bytes computer value? That is unknown to us. Okay. Whether guy will buy a computer or not, that you have to predict. So this X, can I say that this is X1, age is less than 30, X1, and income is equal to medium is X2, and this is X3 and X4. Okay. Now this part is done. P of C1, P of C2 is completed. What do you have to do? You have to complete P of X by C1 and P of X by C2. So let us take P of X by C1. So can I write like that? What is X? This is X. We have to compute the probability of age is less than 30 divided by bias component is equal to yes. Multiplied. How we will do that? Since here in the Navy Bayesian, we have one assumption, it's called as class conditional independence. One attribute is independent of another attribute. So the P of X by C1 is nothing but P of X1 by C1 multiplied with P of X2 by C1 multiplied with P of X3 by C1 dot 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 multiplied with P of X by Cn. Okay, Xn by Cn, right? This is the formula, right? So I am taking P of age is less than 30 divided by bias component is equal to yes, multiplied with the second attribute, then third, then fourth. Okay. So if you look the data, what is this P of A? How we will compute the what is the value of probability of age is less than 30 divided by bias component is equal to yes. There are 9 tuples where belongs to S class. Among the 9 tuples, how many tuples where age is less than 30? So you have to go back to the data and you have to see. There are 9 tuples S class. In the 9 S class, okay, how many tuples where age is less than 30? Here it is 31 to 40, no. It is greater than 40, this is also greater than 40, no. But here you can see there is a one tuple less than 30 and yes. And then less than 30 and yes, 2. Okay, there are 2. So that's why I have written 2 by 9. Why 9? There are 9 tuples belongs to S class. So 2 by 9. Then second one, income is equal to medium with respect to bias component is equal to yes. There are 9 tuples. Denominator is 9. What is the numerator? How many tuples where among the 9? How many tuples where income is equal to medium? 1, 2, 3. Sorry, for S class no. So 1 medium S, medium S 2, medium 3, medium S 4. So it is 4 by 9. So if you perform the same way for student is equal to yes with respect to bias component is equal to yes, you will get 6 by 9. And for credit rating, if you compute, you will get 6 by 9. So this is the value for this is the value for P of X by C1. Okay, then so here I have written separately. Okay, this one I have taken here and I have pasted here. Then we have to do it for P of X by C2, that is P of probability of ages less than 30 divided by bias component is equal to no. So you know that here bias component is equal to no. You just could you please compute this? How it will come? What is this? P of age is less than 30 divided by bias component is equal to no. You know that there are 5 tuples belongs to no. Among the 5, how many tuples where age is less than or equal to 30? Less than 30, no. 1. Less than 30, no. 2. Less than 33. That's it. So can I say it is 3 by 9? Okay. Then multiplied. Whatever the second one, income is equal to medium and bias component is equal to no. Medium and no class. So medium and no 1 and medium and no 2. So can I say 2 by, I'm sorry, this is 3 by 5, right? And this is 2 by 5. The denominator 5 indicates the number of tuples in that class. Then probability of student is equal to yes and bias component is equal to no, right? So student is equal to yes, right? So here you have to see yes and no. Yes and no 1. That's it. I think only 1. So you can say it is 1 by 5. Then the credit rating is equal to fair. Credit rating is equal to fair and no 1, 2, I think that's it. Only 2 by 5. Okay. Now what do you have to do? You have to take these values. You have to substitute. P of x by c1 is this. P of x by 1 is this. Is so substitute here. Okay. And multiplied with P of c1. What is P of c1? We have computed already 9 by 14. Okay. This we have to compute. We will get some value. Okay. Then this also we have to compute. So P of x by c2 we have computed here just now. Multiplied with P of c2. P of c2 is here. This is 5 by 14. Okay. Right. Now we'll get some value. We'll get some value. Just try to compute it. Let us assume this is some 0.28 or something like that. Okay, this is some values. You just compute and see this. Let us say I have some value like this. Now P of C1 by X is 0.28, which is greater than P of C2 by X, that is 0.05. Then if P of C1 by X is greater than P of C2 by X, that is probability of C2 by X,
Sir, we are not able to hear you.
yeah. Sorry, yeah. I hope now you are able to see my screen, right?
We are not able to see your screen.
Now you see, madam.
Yes, yes, sir.
Yes. Since I've connected through mobile, if anybody calls, no, then it's get disconnected. That's the issue. Okay. So I hope participants were able to understand the Bayesian classification. Are you able to see my notepad now? Is it clear, visible to you?
Yes,
Is
sir.
it visible to you?
Yeah, yeah.
Right. So I have explained you how this Bayesian algorithm works theoretically. Now I'll go back to the rapid miner, which you got some result here. I hope now you are able to see the rapid miner's screen result area. You can see here the first class, first row, the model predicted it's no. How? You can see we have applied Bayesian, right? So it is built in here. Now you can see this is the probability value for no class 0.918. For S class 0.082. So which one is maximum? No class is maximum. That's why the prediction is no. So go for fifth row. What is the probability value for no class? 0.323 for no class. For S class, 0.677. Which one is maximum? S class is maximum. That's why you got S. I hope it is clear to you now how this model is working practically and theoretically. Okay. So my request is you must understand the theoretical logic first, then we have to practice. Okay. So this is the way to predict. This is the model. So I have developed one prediction model to predict whether the customer will cheat or not. Okay. I repeat, the read Excel where I am trying to read the data, and cross validation. Why I am using this? I want to divide the data into training and testing. So double click it. So we have training window and testing window. What you used to do in the training window, you will apply any supervised machine learning algorithm here. Okay. So here I have chosen Navy Bayesian. I have applied on this training data and I got the model, right? So this model I am supplying here. So the testing phase, here I will get the model and already have testing data. I want to check the model performance. So I am applying this model which I built on the testing data and I want to see the performance. Okay, right? Clear? Then this is done. Now you have another data where the class label is unknown, which is here, and you want to predict it. So you are applying this model on this data set. Okay, and that result only you are seeing here, how it predicts and it shows. So this is the way to do it in the rapid manner. Okay, clear? And now you can ask me, sir, we have applied Navy Bayesian. Why can't it can be k nearest neighbor? Why can't it can be decision tree? Yes, sure, simple. What you can do? You can just delete this. You delete this and you go for example, I want to apply decision tree. Flow is same. The flow is same. Only thing is I am changing the algorithm now. Decision. Correct? I am supplying this data and we will get the model. Run the process. Remaining same. See, this is the decision tree. Okay, you know that I hope you know the decision tree concept. Decision tree, the outcome will be in tree format. Okay, root node and child. Okay, and then leaf nodes will be there. Leaf node will be your class. Okay, and then we'll have intermediate node, and then you'll have a root node. The logic behind the decision tree is which attribute in your data set is going to act as a splitting attribute. That is the logic. Okay, how to do that? You know that in decision tree there are three category of algorithm: ID3, C4.5. There are three type of algorithm we have, right? In decision tree we have ID3, sorry, C4.5 and CAR. Okay, in ID3 you are using a measure called information gain, correct, to find the splitting attribute. We will try to compute the information gain for all the attributes in the given data set. Attribute which produces the maximum information gain will be considered as the splitting attribute. Then what about in C4.5? You are using what is that? Gain ratio. Okay, you will try to compute the gain ratio. Okay, and which attribute produces the maximum gain ratio, that will be considered as a splitting attribute. Then the last one is under the cart you will have another measure called Gini index. What you will do, you will compute the Gini index for all the attribute which produces least Gini index. In case of ID3 and C4.5, you will go for maximum information gain and maximum gain ratio. But in case of cart, you will compute the Gini index of all the attributes. The attribute which produces the least Gini index will be considered as a splitting attribute. Okay, so this is the logic they are trying to follow here, and then you are getting this tree. Okay, so here the refund may be giving the better gain ratio that you can do, where you can you can see here I have just applied decision tree. It's a generalized model. Okay, we can see you have ID3 also, but I have not applied ID3. It's a general decision tree. You can just keep your cursor on ID3 and you can see the property here. The criterion, they have followed gain ratio. Now I want to see the information gain. Okay, then run the process. See, the outcome is changing. Correct. Now the master status is selected as the splitting attribute. Right. Now we have another one. Random forest. What is random forest? Forest, what is forest? Forest made up of more than one tree, right? Same concept. Random forest will have collection of tree, and each outcome of tree will be collected, and then we'll get the final outcome, right? So just apply the random forest. See, there are many tree, but I want to restrict it. What you can do, you can see. You keep your cursor on random forest. The number of trees is 100. I don't want much tree. We'll go for 10. Now which tree you want to see? This is see first tree, second, third, fourth, fifth, sixth, 7, 8, 9, 10 trees. This is random forest. And you can see what is the performance of the random forest. See, for the random forest, this data it is increasing, right? 70. Earlier you had only 60. Now you got 70%. So it means for this data, this algorithm gives better accuracy. And what is this? This is called as confusion matrix, right? Because which used to confuse us. That's why people have named it as a confusion matrix, right? This is you have to build it, right? We have to build this confusion matrix based on the predicted value. How here I think I have that slide. Yeah, for this is the problem we have considered, no, that bias computer. Now we can see the confusion matrix. This is row, right? This is row. So this is called as actual classes. Actual classes. That means the tuple already belongs to this class. Okay. And what about this? In the column, this is predicted. Your model has predicted. Okay. So what it means? 6954 tuples or rows, we can say, actually which belongs to S class, and your model also correctly predicted it belongs to S class. Okay, this is called as true positive. This is called as true positive. We can shortly write here true positive. What about this? Bias compute. What is this 46? What is this 46? The 46 tuples actually belongs to X class in the data, correct? But your model predicted wrongly as no class. So this is called as false negative. Okay. Then what is this 412? Actually, this 41 tuple belongs to no class, but your model predicted that it is positive class. Okay. So this is called as false positive. Okay. And what about this 2588? That 2588 tuples belongs to no class, and your model also predicted that it belongs to no class, correct classification. Okay. So this is called as true negative. This is called as confusion matrix. Now, how you are computing the accuracy of the classification prediction model? There is a formula. You can see here. I have given some formula here. Okay. But instead of going for that, simple. You add these two diagonals, true positive and true negative. True positive plus true negative divided by total number of data. So true positive is 6954 plus true negative is 2588 divided by what is the total number of data? 10,000. Okay. So we will get the accuracy is 90.411. Right. So this is called as confusion matrix. Based on this, we can compute the accuracy, we can compute the precision, you can compute the recall, and there are a lot of measures to validate the performance of the classifier, like F score, ROC curve, right? So you try to do that and try to explore it. And this is the one example I given, right? It's a simple way to understand, because you know that ABCD, right? So in the actual classes, class is equal to yes, class is equal to no, and predicted is class is equal to yes, class is equal to no. So we have A, B, C, D. Easy, no? Accuracy is A plus D divided by A plus B plus C plus D. What is precision? A divided by A plus C. Only positive classes. Okay, positive recognition rate. The another name is positive recognition rate is called as precision. What is recall? A plus B divided by A divided by A plus B. That is recall. Okay, but accuracy is the better measures. How to do that? How it is happening? How this matrix is built? You can see the slide. Here, this column represents actual in the data. That the bank data I have taken, no? So I have taken only 5 rows. And your model predicted like this. So what happens here? You can see the first row, actually the tuple belongs to no. Your model also says no, correct. Second row, actually it belongs no. Your model has wrongly classified. Yes. Third row, no problem. Correctly classified. Fourth row, it's also correctly classified. Fifth row also correctly classified. Could you build a confusion matrix for this? How to do that? So actual class in the x-axis, okay, and the y-axis the predicted classes, the column. Now first we'll take cheat is equal to no. Okay, how many no's we have actually? 1, 2, 3, 4. But we are predicted. Model also predicted as no. So we have to see no and no combination. No and no first row, third row, fourth row. So 3. Correct? So there are 3 tuples. Actually, it belongs to no, and your model also predicted as no. What about this one? Cheat is equal to no. That is actually the tuple belongs to no class, but your model says it belongs to yes. How many such cases we have here? No and yes combination only 1. So 1. And actually the tuple belongs to yes, but your model predicted as no. Do you have any combination? Yes and no combination? No. You don't have. It is 0. And your actually the tuple belongs to yes, and your model also predicted yes. Yes, that is a 1 entry. So 1. So this is the way to compute the confusion matrix. Now what is the accuracy? 3 plus 1, 4 divided by 3 plus 1 plus 0 plus 1, 5. Okay, so it is nothing but 4 by 5. 90% is the accuracy for this model. Correct? This is the way we have to compute the performance measures for prediction model. Right? There are various measures. Okay, accuracy, precision, recall, FOC curve, and then F score. Okay, I think you are crossing the time limit. I think I have covered, I have done. So I have explained how to implement Bayesian classification in rapid manner. I have explained theoretical algorithm, and as well as I have shown you the demo how to implement in rapid manner, and also I have explained what is confusion matrix. Okay. So if you have any queries, you are welcome, and you can ask me. And suppose if you want to contact me further for any such issues, you can write your mail. This is my mail ID, vengishakti@natk.edu and vengishakti77@gmail.com. If you have any queries, you are always welcome. Madam, I have done, madam.
Participants, if you have any questions, you can interact with sir.
Yeah, please. Pushpalata madam is asking, please. Yeah. Confusion matrix always is confusion, madam. No problem. I will explain here. See here. This is the table where the first cheat column shows actually the tuple belongs to that particular class. Okay. And the predicted cheat, it means the model which you built and you applied on the testing data, and your model has predicted this result. Like no, in rapid manner I have shown no here. Here you have, right? So actually this tuple maybe belongs to some class, and your model has predicted as no. So like this I have taken in the slide here. these 5 tuples belongs to this class actually, but your model says the tuple belongs to this class. So based on these two informations, we can have a confusion matrix. So in the x-axis, that is in the row, you will have actual class. Cheat is equal to no, cheat is equal to yes. And predicted classes will be in y, that is in the column. Okay, cheat is equal to no and cheat is equal to yes. Now, the tuple actually belongs to no and model also predicted as no. How many tuples you have here like this? So you have to see no and no combination. No and no combination. 1, 2, 3. So 3. Okay. And then no and yes. Do you have any combination? Yes. Actually, the tuple belongs to no and model predicted yes. So 1. And yes and no. Do you have any combination? You don't have any combination, so it's 0. Yes and yes. Yes. As for the 5th row, actually the tuple belongs to yes and your model also predicted yes. So this is called as confusion matrix. Okay. Right. I have one more slide here. I've shown you, right? Yeah. So this entry is called as true positive, and this is, that is, if you have S classes, it will be called as positive, true positive and false positive, and otherwise false negative and true negative. Right? Based on this, we can do that. This is another example. Simply to remember, I have given this A, B, C, D, because you know you will get confusion with the true positive, true negative. So many people used to get confused. That's why we have given simple method A, B, C, D. Accuracy is nothing but adding the diagonals. So A is nothing but the true positive, D is nothing but true negative. So true positive plus true negative divided by total number of data. So A plus B plus C plus D. So AD divided by A plus B plus C plus D. This is a way to compute the accuracy from the confusion matrix. Any doubt? Any other doubt? Thank you.
Sir, thank you for your wonderful session, sir.
Yes, yes. Thank you, sir.
Participants are requested to fill the attendance form posted in chat box.
So shall I leave, sir?
Thank you, Venkatesan sir, for spending your time, and you have delivered the predictive analytics with a tool which is useful for every one of us. Thanks a lot for your session.
Thank you, madam. Thanks for the opportunity. Thank you very much. Bye.
Thank you, sir.
Thank you.
Tomorrow the session starts by 10 a.m.